Welcome back. Today's lesson on trigonometry. We are going to look at arc length and sector area. Okay, so this is very important. We have changed. Now we are using radians. Okay, so we are going to change our formulas. Okay, so we are going to learn about arc length and sector area. Okay, so this is very important. Many questions are coming in exams on this topic. Okay, so please stay here so that you can learn something. So our objectives of these lessons are going to be, the first thing is to derive the formulas for arc length. Okay, so we're going to derive a formula for arc length, then and formula for sector area. These are the two formulas we are going to derive today. Okay, so we are going to see how we can find arc length and sector area in radians. Okay, then the second objective is to apply these formulas. Okay, these formulas to solve basic and intermediate level problems. Okay, so we are going to have problems which we are going to solve. Okay, exam question we are going to try to solve using these equations and other what we already know. Okay, so please stay here and make sure you are subscribed so that you won't miss any other lessons on very important topics which we upload here. Let's start by deriving an equation for the arc length. Okay, so here we have our arc length. Okay, so we're going to derive it. Okay, so let's start by writing it out, the information we have right now. Okay, so the first information we have is to find the circumference of a circle. We just have to use the formula 2 pi r. Okay, so this is the formula we use to find the circumference of a circle. Okay, and we know that 2 pi rads, okay, 2 pi rads is equal to 360 degrees. Okay, so this is the information we are going to be using to derive our formula. Okay, so let's say you are given our circle. Okay, this is our circle. We have our circle here. Okay, so let's say the center is here. Okay, so to find this circumference, we just have to use this formula. Okay, but if we want to use a part of a circle, let's say we divided a circle like this. Okay, if we want to use a part, okay, let's say the angle dividing here is theta. Okay, okay, so this is how a sector look like. Okay, so this is a sector. Okay, so we want to find the length of this arc here. Okay, so since it's a part of this one, it's going to be a part of this one. Okay, so this means that this angle is our division. Okay, so we're going to say theta over the total is 360, right, times the circumference of the whole this one, which is 2 pi r. Okay, so I think you understand this formula. Okay, so now we just have to change from degrees. Now we are using degrees here. You can see our total was 360. We just have to change from degrees to radians. Okay, so how do we do that? We're just substituting this 360 to degrees. Okay, so our answer becomes in rads. Okay, so let's substitute this 360. So this means that our answer is going to be theta over 2 pi times 2 pi r. Okay, so this becomes our formula. Okay, so now what you have to do now is we just have to cancel out the 2 pi r, and you are going to find that the arc length is going to be r theta. Okay, so if we multiply the radius of a circle of an arc with its angle in that, you find the arc length. Okay, so this is the formula we were deriving here. Okay, so the formula is just r theta. Okay, let's go on with our derivation. Okay, so now we are going to derive the area of a sector. Okay, so to derive the area of a sector, let's see what we need. Okay, the first thing we need, we have to make sure that we know that 2 pi is equals to 360 degrees. Okay, since we are used to use degrees, and today we are going to be using radians. Okay, so we are going to see that we're going to use this relationship to continue with our workout. This means that 2 pi radians is equals to 360 degrees. Okay, then the other thing is we know that area of a circle, okay, area of a circle is equals to pi r squared. Okay, so we're going to be using this one. Okay, this is the area of a circle. Okay, so let's say we have our circle. Given our circle, we have our circle here. Okay, this is the center. Okay, so this area of this whole circle is equals to pi r squared. Okay, so let's see how do we do with the sector. Okay, a sector is a part of a circle. I think you know that. Okay, let's assume this is the angle theta which is dividing our sector. Okay, we're going to find the area of this sector. Okay, so let's see how do we do that. Okay, so the first thing is we have to make sure we know the formula of this in degrees. Okay, so from this area we see that this whole angle is 360 degrees, and this part of the angle is theta. Okay, so we can say that 3 theta over 360 times the whole area, which is pi r squared. Okay, in this case in using this formula, we can find the area of this sector. Okay, but now we want to change this theta and this 360 to radians. Okay, so how do we do that? We know that theta can be changed to radians. Given theta are in rads now, then we can now change 360 to radians, which is 360 is equals to 2 pi radians. Okay, so we can say theta over 2 pi times pi r squared. Okay, so our duty now is just to simplify this. Okay, so now we now check out this pi. Okay, so in this case we can now have our area of a circle as half r squared theta. Okay, so this will be our formula. Okay, so let's go to our next chapter where we are going to use this equation. Okay, so the first equation was the arc length. Okay, arc length was being given by the arc length was being given by r theta. Okay, given that theta is in rads and the radius is any units. Okay, then now we see a sector area. Okay, a sector area is given by half r squared theta, given that theta is in rads. Okay, so these are the formula we're going to use for next example. This is the example we're going to use. Our example of this lesson is we are given this for this shape, which is OACB. Okay, with the region H here, shaded region H. Then we can see that this OA is the radius of the sector AB. Okay, so it is written here. The diagram above shows a sector OAB of a circle with the center on radius 9 centimeters and angle 0.7 radians. Okay, so we have to know that this angle now is in radians. Okay, so we're going to use it in radians. So the first question says that find the length of the arc AB. Okay, so this is arc we should find. Then find the area of the sector OAB. Okay, OAB, where we should find the area of this sector. Then a line AC shown on the diagram above is perpendicular to OA. AC, this line is perpendicular to OA, and OBC is a straight line. Okay, OBC, okay, is a straight line. Find the length of AC. You should find the length of this AC, given your answer to two decimal places. Okay, so there is one thing I want you to remember. In this case, now when we use our calculator, we're going to use it in rads. Okay, so make sure that you find a pattern on your calculator which is written GRG. Okay, then make sure you change it to rad. Okay, it is r. Okay, you change it to rad. Make sure it is a rad because we're now using rads, not degrees. Okay, so make sure you do that. Okay, then the region H is bounded by the arc AB and the lines AC and CB. Okay, so find the area of H given the answer to two decimal places. Okay, so we're going to find the area of this region H. Okay, so please stay here so that you can know how to solve this step by step and explaining the concept and the tips. Let's go on our first question. Our first question says that find the length of arc AB. Okay, so we are finding the length of arc. Okay, so I remember we said that the formula of arc length is equals to r theta. Okay, r is the radius and theta is the angle in radians. Okay, so r is the radius and uh, theta is the angle in radians. Okay, so let's bring our diagram and take a look. Okay, so here we can see that here we have OA. OA is 9 centimeters, which is the radius of this arc, right? Then we can see that this angle, the theta, is the angle in the center here, which is 0.7, right? Okay, so we can now see that uh, OB is again the radius, since it's an arc, again it's a radius. Okay, so we're just going to use this radius and this angle to find our answer. Okay, so let's go on and find the arc length. Okay, so the arc length AB length AB is equals to r theta. Okay, let's substitute our radius, which is 9 centimeters. Okay, then we multiply it by the angle, which is 0.7. Okay, so multiplying this, we get 6.3 centimeters. Okay, so this will be our arc length here. Okay, so this is the easy step we do it. We just substituted the formula. So make sure you have to remember this formula. It's very, very useful. And now we can say we have successfully found this arc length. Okay, so let's go to our next question, which is supposed to find the area. Our B question says that find the area of the sector OAB. Okay, so we know that the area of a sector. Okay, so let's write our formula, which is the area of a sector. we agreed that this area is half r squared theta. Okay, given that the area radius is n units and the angle is a radius. Okay, so this will be our formula. Okay, so let's use this formula here. Okay, so let's bring out our diagram. Our diagram here, it says that here we can see that we only need r and theta. Okay, here we can see that our r is 9 centimeters, then our theta is 0.7, right? Okay, so we're going to do like we did, let's say our area is being represented by a. Okay, so area is equals to half r squared theta. Okay, this is our formula. Okay, so what we're going to do is we're just going to substitute. This is half, then our r is 9 centimeters. Okay, then our theta is 0.7, 0.7. Okay, so we're just going to multiply this and find our answer. Okay, here it's 9 squared, right? Don't forget that 9 squared. Okay, so our answer becomes 17.15. Okay, 17.15 centimeter squared. Okay, since it's area, it's a centimeter squared. Okay, so this is how we do it. We just have to take our area, our here, and substitute. Okay, so it's easy as that. Okay, now we can see that we have successfully used the area, the arc length and the area of the sector to find something. Okay, so this is how we exactly we just do it. You just make sure you substitute theta and rad and r in any units, and you get your answer. Okay. Now let's take a look at our question 6. It says that line AC, okay, this will require a diagram here. Okay, so let's bring it. A line AC, this line AC, okay, shown in the diagram above is perpendicular to OA, is perpendicular to OA. This means that this is a right angle and it is shown here. This is 90 degrees, okay. 90 degrees is pi over 2, remember, it's pi over 2. Then OBC is a straight line, this is a straight line. Find the length of AC, giving you answer to two decimal places. Okay, so let's take this triangle. We don't need this arc right now. Okay, so let's say our A is here. I usually want to write right angles in this case. Let's say A is here, and these are 90 degrees, and we can see that this is our O, and this is our C. Okay, so we're supposed to find AC, this length. Okay, we are given here is 9 centimeters, and we are given this length is equals to 0.7 rads. Okay, so this is very easy. I know that we usually use a term to find this one. Okay, here we can see that we want AC. Let's say this is our X, what we want. Okay, so here we can see we have adjacent and opposite. Okay, adjacent and opposite. Okay, so this means that we are going to use tan, right? This means that we are going to use tan theta. Okay, this is our angle. Let's say it's theta, which is 0.7. Okay, so this means that we are going to say tan theta is equals to opposite of adjacent, right? So this means that we are going to say x over 9. Okay, so as easy as that. So we're just going to use this equation to solve. Okay, so this is as easy as the other questions maybe. Okay, so this in this case we're just going to go and say theta, we substitute theta, which is in this case 0.8 tan 0.7, which is 0.7 in this case. Okay, 0.7 is equals to x over 9. Okay, we cross multiply, x is equals to 9 tan 0.7. Okay, now before doing your calculations, make sure that your calculator is in rads. Okay, rads. Okay, this is means radian. Okay, we find a button which is written trg on your calculator, and make sure you change your calculator to rads. Okay, or research how to change it to rads. Okay, make sure the calculator is in rads. Okay, if it's not in rads, you're going to get a wrong answer. Okay, so you're going to punch this and get an answer and round it to two decimal places. Okay, now we can see our answer is equals to 7.58. Okay, centimeters. Okay, so this is the length of AC. So now we can simply say AC is equals to 7.58 centimeters. Okay, rounded to two decimal places. This is our answer. Okay, so make sure you punch in radians and make sure you're able to change this calculator. Even in an exam, make sure your calculator, when you are doing this, you change your calculator, your calculator to rads. Okay, so let's see our next example. Now let's go on and solve this question. We saw that we found the length of AC. Now let's see. The region H is bounded by the arc AB, the lines AC and CB. Find the area of H, giving you answer to two decimal places. Okay, so let's bring our diagram. Here we can see our diagram here. The region H is this one. Okay. So let's substitute AC. AC, we found that it was 7.58. Okay. So we are going to start from there. We have 7.58 and we have successfully found this area. Okay. So we found it was 17.15. Okay. It was 17.15 centimeters squared. Okay. This one is 7.58 centimeters. Okay. So now let's make sure we found it. Okay, so the way we can find the area of this edge is if we take the area of this whole triangle and subtract this sector. Okay, so if we know the area of the sector, we just have to find the area of the triangle. Okay, so let's go and say the area of triangle. Okay, okay, the area of the triangle in this case we can say it's half base times height. Okay, we don't have to use this angle since we have this side, but we can use it if you want. But now we can say half base times height. Okay, so in this case, it's half. Our base is 9 centimeters and our height is 7.58. Okay, so we're going to use this and subtract this. Okay, so let's say now we just have to find area of edge. Okay, which is equals to half 9 7.58 subtract 17.15. Okay, so this is going to be the area of edge. Okay, so if you punch on calculator, we get our area of edge as 16.96. Okay, 16.96 centimeters squared. Okay, so this is the area of edge. Okay, so this is the simple way. We have already found the area of this sector, and now we just have to find the area of this whole triangle, then subtract the area of this sector and go get this answer. Okay, so this is going to be answer. Okay, so we're going to be doing many examples and many concepts here. Okay, so please stay in touch and make sure you're subscribed so that you don't miss any lecture and you don't miss any new tips.